Let us now look at the simulation of the flyback converter in ngSpice. We have discussed the theory of the flyback converter, and let us see how the simulation works. This is the circuit of the flyback converter. You have this generic switch here driven by a PWM block. This reference voltage here sets the duty cycle. Minus 0.5 means 25% duty cycle. This magnetics here is the flyback transformer or the flyback inductor, and this is the secondary side diode, and you see the capacitor at the output. So this is the flyback converter. I have placed here a small resistance in series, very small value 0.001 ohm, to represent the winding resistances. See, normally when in simulation the winding is considered as ideal, and when you connect them directly across the capacitance, there can be numerical stability problems during simulation. Therefore, it is a good practice to decouple the capacitor and other sources by putting a very small resistance like this. So this will help in numerical convergence when the simulation runs. So this is the flyback circuit. The flyback transformer here is having a sub-circuit model, and we are passing some parameters as given here. XFM ER NP, the primary number of turns is 100, secondary number of turns 100, C as 10, that is the permeance. The model XFMER, we have seen that, electromagnetic transformer, and it is located, let me close this, the model for the transformer is located in edt01.sub, and all these files are included in the resources section, which you can open and see and test. So now let us look at the simulation of this flyback converter. Now before we look at the simulation, let us just see that flyback.cir is proper. Flyback.cir, you have the transient analysis set of statements here. Dot options just sets the relative tolerance for the voltages and the currents. Dot trans statement, up to 5 milliseconds I am simulating, and it uses the flyback.net netlist as generated from the flyback.sch schematic, the GSM schematic that we just now saw. And as usual, I am setting the background as white, foreground as black or dark, and let us look at the plots of output voltage with respect to the node R, the current VIP, the primary current, and VIS, the secondary current, by sensing the currents in these zero voltage sources. So let us now go to the command window. In the command window, go into the folder, flyback folder. Let me list the files. All the files are in place, and run the simulation. So let me make the netlist and invoke ngSpice and run the simulation. So I will call runsim. Like before, flyback is the circuit that you want to simulate. So let me run this. So you will see that the simulation runs and displays the various plots. So if I zoom in, you will see that the blue is the current in the primary. The blue is the current in the primary. Let me make a zoom of this so that you can. So this is the current in the primary, the blue one. Duty cycle 25, duty cycle 1/3, and because the relationship is d by 1 minus d, 25% divided by 1 minus 25, so you have 1/3. And during the off time, the secondary of the flyback converter, IVIS, the secondary current, is as given by this yellow shaped waveform. So this is the primary and the secondary currents, and you see the red waveform here. This is the output voltage. It has quite significant amount of ripple, and the flyback converter is prone to have higher ripple, poorer ripple rejection as compared to the forward kind of topology. So I will leave it to you to go through the circuit, probe the various voltage and the current points, and try to understand this converter.